Stop right there! I'm Chief Constable Pokdab of the Interpol and you are under arrest. Now you're wondering how we got you, eh? No? You're wondering why you're under arrest? Fine if you want to play it that way. You're under arrest for the murder of Lord Smith. Now there's no point denying it. We in the Interpol have secretly made a DNA database containing 70% of the world population. And we took a sample from the crime scene, searched the database, and guess what? Your name popped up first. Now you can do it the hard way, or you can confess.
Wait a little. This person's name was the first that popped up, you said?
What the blazes are you?
Special Officer Blue aboard of the Interpol Statistics Section. I'm here to assist you with probabilistic reasoning.
I don't need assistance, I'm doing perfectly well on my own, don't you see? And I don't like it that you're appearing like a floating text box. It makes it look like a Stephen Colbert sketch.
Actually, this is a sketch meant to illustrate the concept that extraordinary claims require extraordinary evidence. And I think you're an attempt at a Monty Python-esque police officer.
No, I don't like it. Too simple. I think this really is an arrest, camouflaged as a YouTube video.
Fine. You mentioned that this individual was the first on the database list. Were there any other names there?
Who cares if there's other names on the list too? These tests are quite rigorous, you know. They only deliver one false positive in 10,000 samples. Why wait with the rest?
Because there could be other names on the list, too. Also, is there anything special about being first on the list of matches?
Well, no, there's nothing special about being first on the list. So I'll go and check if there's more people on the list then. Okay, there's about 400,000 other names here too.
So it's not so certain that this particular individual did it, is it?
But look at this individual. Have you ever seen a more suspicious looking character?
Yes, you've got a point. But that's not admissible evidence, I'm afraid.
Fine. I'll go back and run a more comprehensive test then. In the meanwhile, you can entertain the suspect by blathering on about probability.
Initially, the claim is deemed improbable. In order to get a high probability, after the data has been handled, the probability of the data must be much greater under the claim than under the counterclaim. This can be seen most readily from Bayes' formula on odds form. The odds of something is the probability of that this something is true, divided by the probability for that something to be false. Odds increases with increasing probability. Odds equal to 1 means probability equal to 50%. Now Bayes' formula says that the odds after the data has been handled is the initial odds times the likelihood ratio. The likelihood ratio is the data probability under the claim divided by the data probability when the claim is false. So if the initial odds and thus probability is very small to begin with, the likelihood ratio must be comparably high. In order to get above odds equal to say 1, the likelihood ratio must be bigger than the initial odds are small. If the initial odds are 0.001, the likelihood ratio must be over 1,000. The data probability under the claim must be more than 1,000 times larger than the data probability under the counterclaim. There are 6.5 billion people in the world, so the initial probability for you being the murderer is 1 over 6.5 billion. For such small probabilities, the odds will be the same as the probability. The probability of the data given the claim is 1, while under the counterclaim, it's 1/10,000th. That gives a likelihood ratio of about 10,000 and the posterior odds will be 1/65,000th, not enough to convict anyone.
I'm back, and this time there's no stopping me. This test has a false positive rate of 1 in 1 billion, and it delivered one name only, namely yours. That was so satisfying. These tests are great. No more muddling about with motives and establishing who were on the crime scene at the time of the murder. Just one sample and straight to the DNA database.
Hold it. Is this test independent from the last one?
Still playing Mr. Busybody, eh? Well, no, the initial test was part of the more extensive one. But if you're going to argue against a failure rate of 1 in 1 billion, you're quite insane.
Anyway, with a false positive rate of 1 in 1 billion, you would usually expect about 4 or 5 hits, right?
Well, this time it didn't happen. I don't know why the claim that this person did it is so extraordinary anyhow. Somebody had to do it.
Sure, but why this instead of somebody else among 6.5 billion?
Because the guilty one tested positive.
That's using data twice. You can't use data to form the prior.
Fine, let's do this exercise then. What is the probability that this individual was the only one that tested positive, given that somebody else did it?
Well, the chance for this person to test positive falsely is 1 in 1 billion under the assumption of innocence. Independently of that, the killer must then be in the 30% of the population that is not in the database.
0.3 divided by 1 billion. I like those odds.
Probability.
Whatever.
Then there's the chance of nobody else amongst the 70% in the database not testing positive falsely. Assuming independent tests, that is the probability of testing correctly negative, times itself 4.55 billion,
right.
Which is about 1%.
So that is 10 to the power of minus 9 times 30% times 1%. That's 1 in 315 billion. Extraordinary enough for you?
We need the other probability, too. The probability that this person's name is the only one on the list, given that this is the murderer.
Calculate away. Nothing can ruin this moment.
Well, the probability for this person testing positive then is about 1. But the probability of no one else testing positive falsely is still about 1%.
Whatever.
So the likelihood ratio will be 3.33 billion. 6.5 billion was required in order to increase the probability above 50%. This only raises the probability to about 33%.
That can't be right. You must have made an error somewhere.
Look at it like this. With 1 in a billion chance of false positive, and 4.55 billion in the register, there's a greater probability for a total of 1 false positive than none. In fact, it's about 5 times as high. But getting 1 positive test requires 1 false positive if the murderer isn't in the register, and no false positives if the murderer is in the register. So the presence of exactly 1 positive test is evidence that the murderer isn't in the register.
What are you driving at?
This may be our prime suspect, but chances are somebody else did it. I'm not sure if we should rest without further evidence. If we wanted to be fairly certain, we either needed a test with significantly better error rate.
Better than 1 in 1 billion? Most DNA tests are nowhere near that accurate.
Or you need to get more of those 30% that's not currently in the DNA database into it.
I don't believe it. We're not going to arrest this criminal.
Even a 50% chance won't be enough to get a conviction. For that to happen, a probability of at least 99% is usually required. That way only 1 innocent will be convicted amongst 99 guilty.
Should have been the other way around. Right. That's it. You're under arrest.
What?
You know well what for. Obstructing police brutality. I meant justice. As for you, Sunshine, I'll be seeing you soon. I'll do the gritty old-style police work necessary to establish that you were on the International Space Station yesterday.